Okay, good morning everyone. I hope you had a good sleep and are fresh and full of energy. So I'm Thomas Dinges, and I'd like to give you some kind of a workshop, but it's also some kind of a general cycles talk, so I don't think I can fill an entire hour just with noise reduction techniques, so I will also talk a bit about cycles development and upcoming plans, show you some upcoming features, and and then at the end we can also have a Q&A session where you can just ask questions about cycles and everything. So so just quickly about me, I'm developing Blender since 2009. Basically started with the interface back then, and for cycles I worked on the open shading language backend we have, did some nodes, fixes and improvements, and this year I worked for the Google Summer of Code project, implemented things like a new sky shader, subsurface scattering render passes, some new nodes, ported a branch path integrator to the GPU, stuff like that. And I also run a website, openshading.com, with tutorials and infos about OSL, open shading language. So quickly about some things we have been doing since the last year's Blender conference. Last year we were just finished with Tears of Steel basically, and there were a lot of improvements and a lot of development going on. It was really getting into a shape where it's really production ready basically, but we still missed some larger features, which some of them we have addressed over the past year basically. So just last year we worked on open shading language backend, so you can write custom shaders and create procedural textures and everything. It was done in about October, November. Then in December we got hair strand rendering for grass and fur and everything. Later on we got then subsurface scattering, which has been recently completely refactored by Brecht to use a newer and better sampling technique, so you get less noise and a better quality one. That was just released with will be released with Blender 2.69 in a week or so. If you have tested a new release candidate, then you already got the new improved subsurface scattering shader. We also addressed performance in several ways, like just some more clever algorithms and focusing a bit on the BVH traversal stuff, so the actual ray intersection, which is the most costly thing about ray tracing, because every time you shoot a ray it has to collide with all the objects and test if it actually hits one and then does the shading and everything. And we were able to improve that by like 20 and 30% on the CPU and also on the GPU. So between 2.67 and 2.68 I think we got this nice little performance boost. And we had a lot of new nodes for texturing and for texturing, for shading. We got some new closures, like recently 2 new hair shaders, which can be used to make better fur, for example. So just a quick overview of what we've done. Okay, so to come back to smart sampling. So a lot of people think that cycles is slow or not really usable for animation or whatever, and I'd like to take away some of that fear maybe, and give you some tips of how cycles can be used in an efficient way, so you can get nice renders with almost no noise in just a few minutes or so. And just some things I want to talk about first. In theory, I will open Blender later and show you all the things with a practical example. So first of all, you have to understand that cycles is a path tracer, a unidirectional path tracer to be exact. That means that for all the pixels on your image, basically, it shoots out a ray and then it follows up the scene until it hits an object. And every time it hits an object, then it bounces off, or it either penetrates the surface and does refraction, so like for example into a glass object, for example, when you have glass. When you have other things like diffuse or glossy, like a mirror-like shader, then it will bounce off and then hit another object and stuff like that, and it will continue this way until it hits a lamp. And that basically has some, I would say, some limitations. So, I mean, there are more superior algorithms out there, like bidirectional path tracing, where it hits a ray both from the camera and also from the lamp. So the probability that they find each other basically is a lot higher, so you get you get less noise basically in complex scenes. So basically why I'm telling you this is because you just have to keep in mind that cycles is not suited for everything. It's mainly meant for animation and visual effects and everything. But when it comes down to really, let's say, really complex interior scenes with like a lot of glass and you just have one light source outside the window, and you even model the window in a physical way, so you just have like two bounces already when it first enters the window and then it exits the window again, which, I mean, it's a fixed surface, of course. And all the light comes in from outside and you get all this bouncing around, and you probably have to calculate like a few hours of render time. Even if you have a really decent GPU, you will probably spend like 1 or 2 hours rendering. So you just have to keep this in mind, that all those cycles is meant to be a physically based render engine. You shouldn't always think in a real physical way. So if you, for example, want to do an interior scene, don't think like, okay, in real life I also just have one light source outside. I mean, it will work and it will look physically correct, but it will just take a long time to render. And that's just one thing you have to keep in mind and think about. Where can I put some other light sources inside, for example, or fake the glass, so that you have like a more fake glass, for example, which still looks good, but on the other hand for the render engine itself behaves more like a transparent surface, so it's much easier to get through and the light comes in much better into the interior scene. The other thing is like effects like caustics, like all the nice caustic effects you get like with glass, for example, when you have light bouncing off glass and you have like this nice caustic effects. Then on the bottom, this is also a very caustic effect, and you will probably render also a long time with caustics. So those are just two things you have to keep in mind, which are not really suited for cycles. The next thing is we have two integrators basically, a path trace integrator and a branch path trace integrator. They have been renamed recently, so before them they were called progressive and non-progressive. They have been added originally, or the branch path trace has been originally added for Tears of Steel back in 2012. And it basically works a bit different. So, I mean, I don't want to go into the very technical details here now, but the path trace integrator just shoots out a ray and then it just randomly bounces off a surface and it shades just one light, whereas the branch path trace integrator takes all lights in your scene into account at once on the first bounce, and also it takes all the shaders into account at once. So usually using branch path tracer will give you probably a slight longer render time, but you will get a lot faster, decent image with less noise. But I will show you this in practice in just a minute. The other thing is the amount of bounces. When you open up cycles and just start with a scene or so, you already have global illumination enabled, which is something that, of course, it looks good because you have all this color bleeding and stuff like that, which is amazing. But on the other hand, you always have to think about, do you actually need it? Because Blender Internal and Cycles is basically the opposite. In Blender Internal, you basically have to enable features first to get a more accurate result, like stuff like soft shadows or ambient occlusion, fake global illumination, nice mirrored surfaces and everything. You have to enable that. And when you do that, Blender Internal also gets quite slow when you have a lot of glossy reflections and glass and stuff like that. And Cycles is basically the other way around. It starts with all the settings enabled, which provide you with a physically accurate result. So you have like soft shadows and global illumination and everything enabled per default. So if you like to get a more like Blender Internal result, like with not so much GI or so, then you can just have to turn settings down, and then you actually will get a much faster render. You don't have to lose GI at all. I mean, you can just say, like, I take 1 or 2 bounces, which is sufficient in a lot of scenarios. You don't need, like, I think the default is like 8 bounces, which is quite a lot. You probably need them more in interior scenes to light up your scene decently without having too many lights. But when you just have like an exterior or so, you probably, you don't need that many bounces, because you just have sunlight, for example, and it already illuminates all the ground and the characters, and then you maybe just add 1 or 2 bounces to have a bit of fill light and don't have those pure black shadows, so that should help already a lot. If that still doesn't help, Cycles has a lot more to offer in terms of options which you can enable, like multiple importance sampling, which is especially used for HDR images. So when you have like an HDR sky dome with a sky or whatever, then per default Cycles shades that uniformly. So if you have an HDR where you have, for example, like a sun in one position, it will still shoot a lot of rays from other parts which are not as bright. So, I mean, your actual light source would just be the sun, and in real world the energy would just come down from the sun. But Cycles would still uniformly sample all the parts equally. So when you enable multiple importance sampling, it will basically pre-calculate some kind of map which then tells Cycles that, okay, here's the bright spot, here's the sun, and focus on this and shoot all the rays from of the sun, and this will give you a much noise-free result in less time. And it's actually not really not really slower. So if you have like, I mean, it adds some memory consumption to your scene. So when you render on GPU, this might become a problem if you have like too detailed map. But in general, if you have an HDR lamp, then you can just go to the lamp setting, an HDR map, sorry. Then you can just go to the world settings and just enable this multiple importance sampling. Basically, I can recommend it for every sky which is not just a uniform color. So if you just have like gray background or whatever, you don't need it. But even when you have like a sky shader, then it already helps a bit. So you can just enable this with one click. We have some other things which we can enable, like clamping. So you can clamp basically pixel values, and this will help in getting rid of those really bright fireflies, like when you have a scene where you suddenly have those really white dots on your screen or your whatever, then you can turn this value up so it clamps the values at a certain RGB value. So for example, if you have a value of 2, then it will clamp all RGB values which are higher like 2, and then you will get rid of some of those fireflies. You shouldn't set that value too low though, because if you set it below 1, then you wouldn't have a real white, for example. So always keep them between, I guess 1.5, 2 is a good starting point to tweak your scene. We have some other things like light fall off, where you can change the light fall off of your lamps. I will also show you that in practice in just a minute. You can disable transparent shadows, which is also really nice. We only had this globally a few months ago, but recently Brecht added this on a material level. So for example, like when you have some kind, let's say you have a leaf, a tree with lots of leaves, and they used to use image textures there with transparency and everything for the leaves. Then if you don't need a really accurate shadow from those, you can just disable transparent shadows for those, and it will give you a real nice boost. Some guys online, I don't know if you know this Barcelona scene, Pavilion Barcelona or so, which is a benchmark scene or so, where you have a really nice exterior with a pool and a building, and by just disabling these transparent shadows for the trees, you get like a 30 or 40% rendering boost, although you lose some details. So it's of course a trade-off, but in a lot of cases you probably don't notice that much of a difference, so you can just disable that. We also have render layers and render passes. So when you have like an object which needs like a lot of samples to clear up, then you could just place this one on another render layer and say, okay, for this render layer I use like 1,000 samples, and my main scene is like done in like 100. So you don't have to render the entire image with 1,000 samples, for example. And there are also some tricks which you can do with render passes to apply different kinds of blurs, for example, in the compositor, to get rid of some noise. And if you still feel like it's too noisy, then you could also think about outsourcing depth of field or motion blur from the render engine to the compositor and do that afterwards. I mean, but that depends more on the workflow, whether you'd like to do it or you want to get more control afterwards, or you feel fine like doing those kind of decisions already at render time. Okay, but anyway, let's get started with some practical examples. So this is the right one, okay. Okay, so first of all, I'd like to show you the difference between the bounces. I mean, I guess most of you are probably already familiar with it, but just to give you I hope you can see this. Just quickly close this here, so we have more space. Okay, so when I This is just a very simple cornel box to show you some of those effects. And let's just take like 10 samples so it runs fast. When I put down this bounce value to 0, then I basically have the same as in Blender internal. I have an image with no global illumination. So you see you have one light source on top, and you just have the light which falls then basically onto the object, and you have all those pure black shadows then here. And this is really fast, and also you see there's not much noise, and I mean I just rendered with 10 samples, it's like 2 seconds, that's really quick then. If I add more bounces, then you will of course get this nice color bleeding, but it will also take a bit longer, so almost 4 seconds here, 3.5 seconds, and you also see all those white spots here basically, which comes from the global illumination and the strong light source on top. So if you will look closer at the shadows here, you will see you don't have that pure black shadow, but you just have to see how much you need. Basically, I think for Tears of Steel and for the Caminandes movie, I don't think they use more than 3 bounces or so. 2? Okay. So that's already sufficient in most cases, especially when you have an exterior. So why waste resources and having like tons of...
Can you use the microphone for the YouTube device?
Sorry?
The microphone for the YouTube
yes.
Or you can just grab the top one on the podium.
Okay.
That works.
That's true. Like if that's better. We can fix it later on. Okay, yeah, that's better. Okay, so yeah, let's see. Okay, is that better? Or yeah, cloud maybe. It's off. Yeah, it's off already. Okay. So yeah, basically you just have to think about those kind of things, and in general, the more bounces you have, it just adds more render time and also more noise. So you just have to keep this in mind. Okay, let's show you the difference between the path trace and branch path trace integrator quickly. I will go back to like 0 bounces. Maybe I should mention that because I have the impression that not everyone knows about this. Those are basically the maximum values of your scene, but you can still limit the bounces on a per material type level. So yes.
If you turn down the volume a little bit,
There isn't really a switch or so. Is that better? Is that better? Better? Okay. Okay, I guess it's fine now, Andrew. Thanks. Okay. So, basically when we still have just diffuse shaders here in this example. So if I just render with, I already rendered with path tracing here. We have like 10 samples. And then if I switch to branched path trace, that's also, let's say like 8 anti-aliasing samples. You don't actually see much of a difference because you almost have the same amount of anti-aliasing samples. But now with branched path trace, you can say that basically this kind of noise we have here comes from the light source because it's shadow basically. So we can just crank up the mesh light samples here because we have a mesh light here. So just increase this to 2, and we have this info text here at the bottom. So you see that by increasing this value to 2, we now have 16 mesh light samples because we multiply the amount of anti-aliasing samples with each of those, I always call them like sub-samples or so, and basically it multiplies them. So we would still have like 8 anti-aliasing samples, 8 diffuse and everything, but 2 mesh light samples. And if I take another render layer here again, and you see it's, I don't know if we can see it good on the projector, but it's like, that's with the increased one, that's before. So basically you can increase the samples on, basically on what you need. Like if you need a better quality on diffuse surfaces, you just increase the diffuse ones or the glossy ones or whatever. And for shadows you need either the mesh lights or when you have like a regular lamp, you can then go to the lamp settings and increase the samples here, for example. Another thing, I mean this is a quite easy example, but if we flip those and have like a glass sphere, and I will go back to, let's say, just 10. So I render with 10 samples. Well, I guess I should increase the bounces again so we actually see something. Okay. Maybe I will just quickly enable the render passes so we can see the effect better. Render it again. And then with branch path tracing, okay. And now when we go to our render passes, which is like glossy indirect in this case, you see a big difference here. So this was basically the regular path trace one, and this is the branch path trace one. So as I said before, the branch path trace just shades it in another way, so it takes all light sources into account on the first bounce and also all BSDFs, which can result in a, I think I noticed it especially with glossy surfaces, glass and stuff like that, and also when you have a lot of lamps. So this is something which is really, really helpful. You also see it here in when you take a look here at the mirrored reflection from the lamp, you also see a huge difference. So normally I can really recommend you to try this out, and there are some great tutorials online, for example on CG Cookie. Matthew Heimlich just made a really great tutorial about the branch path tracer, where he explains like how this works and how you can fine-tune your values. So basically it's not that difficult. I mean, some people are getting a bit they're a bit afraid of those values here, but it's basically really simple. I mean, instead of just having one kind of sample value which then samples everything with 10 samples or with 100 samples, you can just you have more control over your sampling. So it's basically really simple, and you only have to keep two things in mind. If you use things like motion blur or depth of field, you need more anti-aliasing samples, because those kind of things are affected by anti-aliasing samples. But if you don't have depth of field or motion blur, you can just keep the anti-aliasing values quite low, but then increase the diffuse value or the glossy value, so glossy materials and diffuse values, for example, get sampled better. And this is nice then, because if you crank up those, again I say subsamples or whatever to illustrate it better, this is actually faster than having a lot of anti-aliasing samples. And basically what we have here in the regular path trace integrator, that's like, all of these are like anti-aliasing samples, so you can compare this value. So when you have like 10 here and set like 10 here and everything here is at 1, then you basically almost get the same result. Due to the way it renders and takes, like, as I said, all lights into account, for example, it will probably still look better, but it probably will be just about the same. So,
Yeah, so you could say that the normal path tracing, that's kind of like a sort of an easier version for people to use, but the branch one is more control.
I wouldn't say easier. I mean, there are a few reasons why we just don't have branch path trace. I mean, one of them is basically that the regular path trace one is still faster on the GPU, for example, because it's just simpler and everything. And I found that if you have really like a lot of samples, like if you have a really complex interior scene or so, then I think the branched path tracer is still either slower or so you could just as easily just take the regular path trace one. So it's great when you just have, like, for example, 0 bounces or 1-2 bounces, then usually you will get a better time noise ratio with the branch path trace integrator. But when you just want to have a quick render or you just render on GPU or so, then probably the regular path trace one is better for you, but you have to test this out. I mean, what is a good way of doing it is basically when you render a scene with 100 samples in the path trace one, just switch to the branch path one and then just analyze your scene quickly. Okay, I have 2 glossy spheres here, so I will just increase the glossy samples a bit, and the shadow is still a bit noisy, so I will increase the shadow samples and just test render it. So you can always look at this label here, which says that now I have like 30 glossy samples. So if you say, okay, I'd like to have those 100 samples which I had before, but just for the glossy samples, I just increase this to 10, so I have 10 multiplied with 10, and then I have still my 100 glossy samples, but less diffuse samples. So you basically can just, yeah, you can fine tune it more better.
Will it get faster on the GPU in time?
It could become faster. I mean, we can always add like better algorithms or stuff like that, but yeah, I mean, the plan is, I think, to also just refactor it and maybe get rid of it and add more options to the regular path trace one, so you can make the path trace one behave like the branch path trace one, but we have to see. I mean, yeah. But there are a lot of other things you can do, like still on the CPU, for example, like doing better work with the BVH ranger section and stuff like that. I mean, there are a lot of things which we can do, but I mean, there's just not one single switch you can just press and then it's 3 times as fast. You can get like a few percentages everywhere, but it's not like there's one piece you work on and you get your ultimate render boost, so it's just time consuming and difficult to increase it, but it will be worked on definitely, yeah. I think the plan, yeah, back please.
Maybe I should explain about the branch. Okay, it doesn't work.
Is it on the green light? Maybe.
Yeah, okay, now it's on. Well, about branch path tracing on the GPU, it's basically the algorithm isn't really suited to the GPU, but there's sort of a new kind of algorithm that's for rendering on the GPU that's sort of becoming popular, and that a lot of, well, there's not actually any render engines using it yet, but I know for a fact that there's like a lot of companies investigating something called wavefront path tracing, which we would like to do as well eventually. But at the moment, like regular path tracing is better suited, but maybe in the future it will work. But it's like a big architectural change that's sort of happening and people are researching it.
Mm-hmm.
Yeah.
Okay. So another example I've prepared to show you the benefits of branched path is like if you have multiple lamps. So in this case, I mean, I would just use viewport rendering here, shows it better. So when you have like regular path trace, it always just picks one lamp and samples this one. So you see we have like 10 samples here, and it's still really noisy. And if we switch to branch path trace, it will sample all the lamps just at once. Every sample it takes longer, because you see we have like 4 samples now, which is like 6 seconds, and before this it was like, yeah, it's a bit faster, but you see just the difference. So I mean, you don't have to think about it like in terms of render time. I mean, if you can, it doesn't matter if it takes 1 hour or half an hour, if the 1 hour one is like 3 times noise free than the half hour one, so you still have a benefit of this. So yeah, you can either just make the same code run faster or just have it take a bit longer maybe, but you will get a much more clean image. So that's 2 ways you can approach it. And just to illustrate again, you see like after 1 sample you already have like a perfect clean image here. So that's just 2 things you basically, where the branch path trace one is really good, like when you have many light samples and when you have a lot of glass or glossy objects or stuff like that, and when you have not that many bounces, then I can highly encourage you to just test it out and check it. Okay. So I showed you the bounces and everything. What am I importance sampling. So you have to just, I don't think I have an HDR on my computer at the moment, but to quickly just show you the button, when you have an HDR, I guess I could illustrate it with the sky shader. Got pretty good results with that. Just like, yeah, this one. So we just have a few cubes here, and I will just enable a sky shader for this, and yeah, let's see where the light is coming from. Okay, let's see, so we can see the effect better. Okay, I make it a bit more strength even.
What is the turbidity?
Sorry?
What's the turbidity value?
Dirty of the air. I guess with the dirty of the air is the more reddish get the light. So typically when you have a very clean air, even when the sun is on the horizon, it's still kind of blue. But
Yeah.
when you like in very dirty areas, you see it gets very reddish.
Yeah, you can basically also say that like smaller values are more like a regular sunny day, and then when you crank it up, it's more like a desert-like sky or so. Yeah. Okay. So, sorry, I'm just not really used on using Blender without a mouse. So. Okay, I think we should see the effect pretty nicely here. So when I render this is now with importance sampling turned off. So yeah, you can see like we have a lot of noise here and there and everything. And we have like 4.7 seconds, and then I just enable this multiple importance sampling, which will then create a map basically, and then it knows where the sun is or where the bright spots are, and it will sample those from those positions. So we'll just switch here. Yeah. And if you compare this, like, especially here in the background, then you see you have less noise than before, basically. Also here on the bottom, if you look closely, that's afterwards, that's before. So, and it depends on how much memory you have, or yeah, I mean how complex your scene is. I mean, if you just have an HDR, so with one bright hotspot like a sun, for example, I guess the default of 256 is pretty fine. But when you have like a map with a lot of light sources, then you probably should increase this value to have a more detailed map. Yeah.
I have the problem that when I have an HDR image or a skylight, that it doesn't really like the scene. So the usual for reflection is good, but here with the sunlight, there's a sunspot, and it doesn't cast shadows. It's like just random brightness. Is there any possible to make these fit better together?
You could use a multiplying thing to, I saw like a screenshot.
Yeah.
You had a multiplying plug in, and it like doubles the darkness value of the top of
Yeah.
the original one. It gets really good shadows from the sun.
Okay.
Works really well.
It is weird that, for example, if you have Maxwell and you have this exact same HDR, that it will really give sharp shadows.
Okay.
In Blender, it's like the sun will maybe have a value of maybe 10,000 or something, really insanely high. And in Blender, for some reason, you don't get the same sharp shadows.
Okay.
And I do Andrew's trick usually by just multiplying it. But it's good.
Yeah.
So you talk about the HDR now, or the
Yeah, the HDR, how real dynamic range is handled.
Is it the strength setting in the HDR, or where do you change the...
Yeah, just multiply the HDR to make it pop even more, so till you get shadows. But sometimes you need to really multiply it up and increase the resolution a lot to get shadows.
Brecht, maybe you know this.
Well, I mean, if the resolution is too low, it might not actually capture like the sun, and the sun is sort of smaller than the resolution. So you might miss the sun, but I mean, if there's like a huge difference in like shadow sharpness or something with other rendering, then maybe that's a bug or something. Send me a file.
Multiple importance sample.
Sorry?
back at the multiple
Yeah.
impulse sample, is there a downside to having it on? Does it use much more memory or?
Well, it uses a bit more memory, and it's slightly slower, slightly. So if we just compare it, we have like 4.7 seconds with it disabled and 5.48 with it enabled. So it of course has to do a bit more calculations, but yeah, you get, it depends. I mean, I don't think I get more if I increase this, but yeah, usually when you have an HDR, you really get the effect. So yeah. And if I would take fewer samples, like let's say just 5, and have this disabled and then enabled, yeah, you can see the difference, I guess, of all these brighter pixels.
Can you explain the map resolution?
Yeah, it's basically when you just, as I said, when you just have one light. So yeah, how should I explain? Basically, what Cycles does, it creates some kind of black and white map of the HDR, and it knows everywhere where it's white, the light is coming from, and then it can sample this with more importance, basically.
So the higher the value, the
Kind of a texture, I guess.
Kind of a texture,
Like,
yeah.
oh, okay, right.
Yeah. So basically, because without it, Cycles just sends a ray from each position on the HD. Sorry?
Sort of dome map.
Yeah.
So divided 50,000 times.
Yeah, so that's the whole trick behind it. So basically, it analyzes the image at first, and it knows then where the bright spots are, and then it sends the light rays out of from there, and then basically you get more, because you don't. I mean, you still have the same amount of rays basically, but because you're focusing on this point, all the rays come from this point. Whereas with the regular one, you would waste like rays coming from the black night, where you don't get any light at all, because this black value just doesn't add anything.
If somebody asks a question, could you repeat it in the microphone? So
Okay, okay. Okay. Other things I'd like to talk about a bit is, for example, the light fall off, which is also nice. And I guess I will go back to my corner box scene. If I render this here, let's make it a bit faster, just do like 10 samples. You see, we still have a lot of these, kind of bright highlights here everywhere. And that's because the lamp is pretty strong, I guess. It's like, let's check it. It's like, there's a value of 3 in the strength, which is, for such a mesh lamp, it's quite a bit. So we can use the light fall off node to actually change the fall off of the lamp. So basically, it will be not so strong in the near vicinity of the lamp, so we don't get this like really bright hotspots there, and it just samples it a bit differently. It's not really accurate then anymore, I guess, but that's basically a trade-off, but most of the time you probably won't see the difference. So if I just go to my node editor here, have my material output, my emission, and then I can just take this light fall off node and then connect one of these with my strength input. So when I take like the linear one, take back to so we had a strength of 3, I will change it back to 3. Go back to the spot. Yeah. And you see we have already quite less. But we also said that the lamp is, the fall off is different. So we have like, So you also see this here on top. Basically, if you take a close look at the edge here, like now it's almost white, and then we see more of this here. That's basically some stuff you can do to get rid of those extreme spots all around by losing a bit of physically accuracy, but you can also play around with the smooth value here, which will smooth then the fall off even further, so you even get like less of the noise, but then you also lose some kind of of brightness, because the light fall off is then so yeah, it's weaker than in far away, in more far away parts of the image. So you maybe need another light source or so. And in this time you also see that you don't even see real light here anymore on the rim. So it's like complete gray again. Yeah.
So the linear path makes it behave a bit more like the sun, and it doesn't, it's more constant, like it doesn't fall off as quickly. Is that what
I think that the default is quadratic, I think,
Yes.
without any node, yeah. So basically you can just change it to the other stuff. Yeah. Okay, one more thing maybe. What's the best scene to show this? I mean, or every time this Lane Cornell box. Go like, for example, yeah, maybe this one, to show it a bit. If you have like, maybe, yeah, let's see. Just to illustrate you the effect of clamping, basically. So this is not the magic key solution or so. Again, you shouldn't turn this value too low, because otherwise you lose brightness and contrast in your scene. But it can help if you have like real bright hotspots, for example. So when I would turn this to 1, I don't think we will see that much of a big difference here. Yeah, not really, because we don't really have RGB values which are above 1. But if I would say, to show you this extreme effect, like just 0.2, and render it again, you will see the image will be a lot darker.
Does it remap in some way the signal? Because I found if you have a clamp of 15, for instance, all the values in between 1 and 15 are mapping away. If you move to, let's say, 5, everything is smoothed, not clamped in a real way. I mean,
Okay.
just cropped away.
Basically,
There's still another thing about this clamping. It's the way I see it, and it doesn't really clamp the output value of the color of the pixel. I mean, it clamps like the individual components.
yeah, it clamps the sample, I think.
It clamps the
In the-
samples, not the image as a whole.
Yeah.
Yeah.
I don't know if this works. Okay. Well, what the clamp option does is it clamps each individual sample to a value. So if you have like a really bright sample, like a firefly, it will clamp that. And actually, I think you can set clamp a lot higher than 1 or 2. Like you could even set it to 10 or something, because sometimes you get a value of like 1,000 or something, because for some reason it's like super bright. And it's mostly like, if you have one value of 10 and then have a few lower ones, then in the final thing it'll even out anyway, so it's not really a problem. But it's mostly like to stop those super high value samples where you have 1,000 and they throw the entire thing off.
And this clamp would affect samples. This clamp would affect things and samples even if they are not on camera, like light coming from a window, and it's lighting the floor, that then is the second bounce lighting an interior scene. If the clamp is set to 10, let's say, the light on the floor, even if we don't see it on camera, will be clamped and not generating GI for the rest of the scene too.
What it clamps is like the final value that I don't even know if it's working, but it clamps like the final value that arrives at the pixels. Like it doesn't clamp like intermediate values in like the pad bouncing around. It's just like if you render with one sample and and you said clamp, that's sort of what it does. That's like if you run with one sample and you would just clamp it in the compositor, that's sort of what it does.
Yeah.
And if you would do that for each individual sample and combine it together, that's the result you get. So it's not like if there's a super bright light coming in from the window and then it hits like a black surface. There's nothing to be clamped, It's only when you actually get a very bright sample at the camera, that's where it clamps.
Okay. I don't have a real example now for transparent shadows, and but that's basically just one button, so you can either disable when you have like leaves, for example, as I said, and you have transparent shadows then coming from them. You can either just disable this globally here where it says shadows, that's still belongs to the transparency, or you can go to the material level and here under the settings panel you can disable transparent shadows here as well. So one of these, if you want either to disable them globally or on a per shader level, that can be done here. Okay, so we don't have much time left, so I still would like you to give you the chance to ask questions and stuff like that, but I also would like to give you a very brief introduction to volumetrics, at least what we have already in an experimental branch still. Because this was originally developed by some guy named Storm on the forums, and later on got picked up by Stuart Broadfoot, who also did the hair stuff in Cycles, and he cleaned it up basically and refactored it and extracted it from this one big patch from Storm, because he also adds like other things there. And then I also came along and did some cleanup and stuff, and then we committed it to my branch, my Google Sum of Code branch, and you can check this out. And if you like, if you go to Graphical and search for the Sum of Code Dingto branch, then you will find this. Just a very quick demo, because probably the UI and everything will still change, and it's really experimental. There is no support yet for stuff like smoke or so, it's just like volumetric objects and volumetric procedural and volumetric stuff. So here, for example, we have volumetrics applied to the world. So you see we have, you now get on top of the surface socket, you also have your volumetric socket. I mean, in the node editor you always see the node, the volume socket, but now with this patch you can use that as well, and we have like the isotropic volume closure, which will probably be renamed, but anyway. The naming is a bit confusing still. Then you can have stuff like the density, which you can change, like whether your volume should be more dense or, so as you can see now you get almost nothing here, because it's so much dense that the light source isn't strong enough. That's one thing you can do, just apply it to the world basically. Where's my light source? I think maybe I can demonstrate it. If I change this to a spot, for example, you get some kind of those volumetric light beam like effect, which you can use. And you see it's not really slow. I mean, we just have like 10 samples here. It's where's the sampling panel? Here. Just increase this, so you get a quite decent image quickly. So for that, the code is already pretty nice, but when it comes to more complex stuff, then it's still a bit slow. But you can see you can create like basic effects like volume beams and stuff like that. Which is important, what is important here is basically the scattering value. You just get single scattering with a value of 0, I think, or it's 1 actually, I'm not exactly sure. But it basically just, the light hits the volume and then just scatters around one time. Whereas when I increase this, it does multiple scattering, and you already see we get some effect outside of the actual light cone. But this is really noisy and slow, but so you have to see about where we can get it still. So that's one thing basically, to use it for the world. You could also just model a cube basically and use that to get a volumetric like effect. You don't have to apply the volume shader to the entire world, of course. And then the other thing is, here's some example with volumetric procedural texture. So you see this is basically just a cube with 8 vertices, and then you can have all kinds of shaders and basically tweak around this stuff, and you get like nice effects. You can basically do some kind of procedural modeling and stuff like that. That's actually what I really like, and that's what has been implemented by Lukas Tönne. He worked on open shading language in combination with volumetrics. So I mean, until now we could only use open shading language for like surface shaders, so you saw all kinds of procedural textures online, but with volumetrics and later on displacement also, it will we will get a lot more freedom on doing stuff like that. So I can pretty much imagine that people will, for example, write a shader where you just put like a box or somewhere, and then you will have a cloud shader which generates a nice cloud out of it. So those kind of things will be possible with all these kind of things. Anyway, just a quick demo. You can check out Summer of Code Dingto branch from Graphical or compile it yourself. We don't have a time frame for it. I mean, I'd like to get it in trunk, maybe hopefully this year still, in some kind of early experimental stage, but we will just see about it. I mean, we're really busy with all kinds of stuff at the moment, like interface and everything. And yeah, also the migration to the new servers, to Git and the new patch tracker and everything. So I have no idea when we will have the time to polish it to a state where we can put it into trunk, but just wanted to show it to you because I know a lot of people are excited about this, especially later on when it comes to smoke and everything. So, yeah.
I was going to ask that smoke. So how is that a lot more complex to
Yeah, basically volumetric rendering will be there then, but you still have to basically get the voxel information out from the smoke simulation into the actual render engine, which we don't have yet. I mean, we had a Google Summer of Code student who added the OpenVDB library, which is a pretty common library which is used in other render engines these days to store those kind of voxel data. Maybe I can just quickly OpenVDB. Oh, that's nice. So basically it's just a library which then can store those kind of voxel data and bring it to the render engine then. And you can then create all kinds of stuff with it. And you can also just then load in an OpenVDB file from another application, like I don't know if or which applications do support them, like if there is an application out there where you can create those kind of cloud stuff or fire simulation and then export the OpenVDB file and load it. But I guess it's possible in theory, Brecht. Or isn't it?
Yeah, I mean, it shows on the page, like with Houdini, you could create like a cloud simulation and then render it in cycles in principle if we support it. Yeah.
So that will be really nice, but I mean, it's our experimental volume code in my branch, and then the student has this integration work, so we still have to polish the actual volumetric code and then combine it with the OpenVDB stuff, make it work with smoke and everything. So yeah, we'll see about it, but that will probably come at a later point. So first basic volumetrics like you saw here, with the light beams and stuff like that, and then later on smoke and stuff like that, yeah. Anyways, we have like 7 minutes left, so everyone who has just a question related to my talk or cycles in general, I mean, we have Brecht here, and so, yes, yeah. You can just pass the microphone, yeah, so people will, exactly.
It's there, test? Okay, yeah. We got the subsurface scattering shader on Cycles, and the main problem with this shader is that this has no transparency. So when you have, for example, a milk bottle and you put something in there, it doesn't go, like, it looks like it's transparent because of subsurface of the shader, but you can't see something below the surface. Is there something planned that we can achieve this effect with the shader, or is this not supported from the subsurface scattering shader at all?
Well, I mean, yeah, but I guess, I mean, it's not, I mean, you always have like...
Yeah, I mean, of course you can like add like a transparent shader or like a transmission shader in addition to your subsurface scattering shader, but maybe what you're talking about is like subsurface scattering between different objects which do not have the same material. And I still want to add like a control so you can have a specified group of objects between it, which it will do subsurface scattering, which I think maybe is what you want, but I'm not quite sure.
So in the old render engine I did some things like I had a static building and I wanted to sort of create a fluid which builds up from the bottom and then fades, so becomes transparent, and at the same position the building has to become visible. so non-transparent. And I controlled this with an empty and just enabled the object control in the texture settings. And even with in Cycles, even with the object info node, I haven't been able to recreate this effect.
Well, I don't think we have actual control with empties and textures in Cycles.
We will add this
But I mean, you probably can use like a mix shader and animate the factor value and blend between your regular material and the transparent closure, for example. If that would help. I mean, the object info or visibility info is basically just on and off, I guess. And if you want to blend between those, you can just use just like a mix shader and blend together like two materials and animate a slider here. So between fully diffuse and fully transparent or so. So you can just animate that, of course.
Okay. Well, the materials itself were extremely complex. So for the building, I had mix shader, glossy shader, glass on top for a crystal or something, and the fluid which builds up is some sort of glowing material. So it was.
Yeah, but I mean,
it was really hard to create this effect.
You could still have like your dozens of closures here and then one transparent here, and just have your complex material set up and blend between that complex one and a transparent one. So that's not really a problem, I guess.
Okay.
Yeah. So you can have like a diffuse, glossy, and everything, blend effects, and just fade it with a transparent one. Yeah. Okay. Other questions? Yeah.
I'm sorry, my voice went away. Do you plan to have a better integration with tools in the compositor? I mean, for instance, we have ID material that we cannot use with transparent objects that are in front of the other one that we want to sample, for instance. This is not possible at the moment. We have to make two render layer, but we don't have the reflection of the material, or better, the displacement of the material we are getting through. And also, I would like to know if you will plan something about how to use combining non-color layers with motion blur. That is not possible at the moment, or not really possible.
So I guess we can add all kinds of those kind of smaller features. Basically, I mean, we have a to-do list online, which where a lot of smaller stuff is basically. I mean, mainly it's just about telling us what you want and what's missing in your opinion, and we can just check when we get a time or some other developer picks it up. I mean, we have. Yeah, I mean, I wouldn't say it's really low-hanging fruit because it's the code is nice and everything, but it's just you have to get into it first. I mean, ray tracing and everything is just not so easy, and you also have to understand Blender internals if you wanted to work with the compositor and everything. So, but you can just email, for example, or come to IRC and talk to us, and we can see if we can figure something out. Sure.
Okay, thanks.
I don't know if there's been some information recently which I might have missed, but is there a definite answer to the optimal tile size? Because that's something has been debated quite hotly, and I never seem to really been able to nail down exactly what is the optimal tile size.
Basically, I mean, it is a bit of trial and error, but it also, it depends on various factors, like mostly the hardware you use and the scene. The rendering, but usually a small tile size like 1616 or 32 is best for a CPU, whereas on GPU it just feels more comfortable with a bigger tile, so like 256 or so.
Should X and Y be identical? Is that the big point?
It's not about those. I don't think it's really necessary to have them. I mean, like Arnold, for example, just has one value, so it automatically squares that. But if you like to have like a non-quad like tile, you can do that, but it's not really the point. Basically, it just depends on the tile size. So bigger tiles are just usually better for GPU, whereas small tiles are better for CPU.
From my own experience, it's the best when you have
the image length and use this as a tile size. So when you have an HD image, then like 980 x 400 something is then like your ideal size. Like only make the image with 4 tiles when you're on GPU. That's the fastest I can get. Also not like 512 or 256. It's half of the image size.
Only if you've got only one graphics card. So it depends on the amount of graphics cards in your PC. So if you got 2 or more cards, you should have 4 times more or 8 times more tiles. No?
Brecht, you want to add something?
I just want to say, like, I'm not happy about this situation at all, the fact that you have to manually tweak this, and I have some ideas to solve it automatically so that you basically would specify small tiles, and then one GPU would render multiple tiles at the same time, and then some way we would figure out automatically how many tiles it should render at the same time optimally. And this is kind of complicated to do, but I know we're sort of in a situation now where you have to do lots of testing and stuff, and I'm not quite happy about that, but I'm thinking about trying to solve this.
Okay, so yeah, maybe one more question because we're running out of time a bit. Maybe there in the back.
I came here to solve a rather hard task of interior scene where I have hundreds of lights, and I see very many ideas for doing it, but I still find that one of the things that you have on your to-do would solve the problem rather easily, and that would be me making it on light groups. And the question is, I know that the light groups are coming because you have it on your to-do list, but the question is, do you have any scheduled time frame for it?
So I mean, you guess I guess you mean like light groups like we have in Blender internal, so you can.
Yeah, or just lighting the layer that the layer that the light is on.
Okay. I guess it shouldn't be too difficult. It's one of the smaller ones, but yeah.
Yeah, because the ceilings are killing me, so that would be very nice.
Yeah. Okay. Yeah, we don't really have we don't even have a real plan for 2.7, so I mean, as I said, we are really busy with all kinds of stuff, so we don't know how much we can add for 2.7 for cycles, but those smaller things we can always just pick one, but yeah, it's just a matter of priorities and time, as always, I guess, yeah.
Thank you.
Yeah. Okay, so thanks everyone, and yeah, feel free to talk to me during the conference still if you have questions or a more specific problem or something like that. I'm happy to help you out. Okay, thank you.
¿Ves algún